Okay, in this chapter what we're going to be looking at is radicals, and we're going to look at right now an introduction to radicals. The parts of a radical, and a radical sign is basically we're typically used to seeing square root. This is called a radical sign. What's underneath the radical sign, or inside the radical, is called the radicand. The number in front, or outside of the radicand, is called the coefficient. The little number that is right on top of the radicand, which may not always be there, but that's called an index number. And finally, the entire thing is called a radical. A couple more definitions. An entire radical has only a radicand, or in other words, there will be absolutely no coefficient. So examples of entire radicals would be something like square root of 2n, or cubed root of 4x, anything like that, or just cubed root of 4. A mixed radical, on the other end, has a radicand and a coefficient. So an example of a mixed radical would be something like 2 root 3 or 5 root 4x, so it would be considered a mixed radical. Finally, a radical in simplest form, if we're asked to put into simplest form, has absolutely no fractions in the radicand, and also no factors that can be removed in the radicand. We'll be looking at that in some of the examples coming up. First of all, what we're going to be looking at right now is going from a mixed radical to an entire radical. In order to do that, what we need to do is get the coefficient inside the radicand, and that depends on the index. In this particular case, since it's square root, our index is technically a 2, which means in order to move something from the coefficient into the radicand, we need to put in a pair of them. So to do that, we have to put in a pair of 2. So this will be the square root of 5 times 2 times 2, which is equivalent to the square root of 20. So that's the entire radical. In this next one, just as a reminder, an exponent of a half means square root. So in this particular case, to do this, what we would do is put this 2 in as a pair. And what you'll notice that I'm doing is not putting the negative in, because that will actually change the value. You get the square root of 20 instead of the negative square root of 20. So negative parts of the coefficients can't be put into the entire radical. In the next example, because your index is 3 right here, what that means is that instead of putting doubles or twins into the radicand, we have to put triplets or groups of 3. So in this case, it would be the cubed root of 54. Finally, this last one, we'd have to put in 4 groups of 2. So this would be negative index of 4, 5 halves times 2 times 2 times 2 times 2. In this case, what we can do is cancel out or reduce this fraction. So it'll be negative index of 4, and 5 times 2 times 2 times 2 is 40. So that is our entire radical. What we can also do is go the reverse way, which is go from an entire radical to a mixed radical. Those of us who are good with our perfect squares, what we want to be doing, or perfect cubes, depending on the index, we want to be looking for perfect squares or perfect cubes, etc., depending on the index. So for the first one, what we could do is, you may notice that 12 has a perfect square of 4 in it, which is square root 4 times square root 3, and square root 4 is just 2, so it would be 2 root 3. For those of us who aren't good at finding our perfect squares, what we can also do is a factor tree with the number that's in the radicand. 12 is 2 times 6, which is 2 times 3, so we can see that this would also be square root 12 is the same as square root of 2 times 2 times 3, and these twins, because your index is 2, can come out as a single 2, so it would be 2 square root of 3. So either way you look at it, that's what you get. In this next one, for those who are good with their perfect squares again, you'll see that this is negative square root of 9 times square root of 10, which is negative 3 root 10. For those who aren't, here is your factor tree. 90 is 2 times 45, which is 3 times 15, which is 3 times 5. So you'll see that 90 has, so it's negative square root of 2 times 3 times 3 times 5, and this pair of 3's can come out as a single 3, leaving us with negative 3 square root, and then just multiply the remaining factors in the radicand. That becomes negative 3 square root 10. Finally, in our last one, you'll see that the index is 3, so we have to know our perfect cubes, which is far more difficult, but for those who do know that 2 times 2 times 2 is 8, you may be able to do this, and you would get that this is 2 cubed root of 5. For most of us, what we should be doing is doing a factor tree with 40, which is 2 times 20, which is 2 times 10, which is 2 times 5, and realizing now that what this is the cubed root of 2 times 2 times 2 times 5, and these triplets of 2's can come out as a single 2, leaving us with a final answer of 2 cubed root of 5. Finally, you may be asked in some cases to compare radicals that don't look similar whatsoever, but if they do have the same index, which 3 of them do and one of them doesn't, we'll talk about that one in a second, what you can do is make them entire radicals, and then you can compare the radicands. So in this particular first case, it's already an entire radical, so we have the cubed root of 5. In the second case, to make it an entire radical, this would be 4 cubed root of 2. We could put in a triplet of 4, so 4 times 4 times 4, which ends up becoming the cubed root of 128. In the case of 5, we could also represent 5 as 5 cubed root 1, because 1 times 1 times 1 is equivalent to 1. So in other words, just to make it look easier, we could introduce the cubed root of 1. It's the same. And this would end up being the cubed root of 125. And finally, in this last case, which is probably the most difficult one because of the numbers here, it would be 6 cubed root of 2/3. So we could put in 3 6's, which would end up being cubed root of 432 over 3, which is equivalent to the cubed root of 144. So in ordering from least to greatest, if you look at, now that we have the same index and just entire radicals, if you look what is inside the radicand, you can see that the smallest one by far is cubed root of 5. You can see that the second smallest from least to greatest would be this guy here. Third would be cubed root of 128, and the largest or greatest would be cubed root of 144.